Hello everyone. So in this video, we will try and solve this problem. We have the position of a particle which moves along a straight line is defined by the relation x is equal to t cubed minus 6t squared minus 15t plus 40, where x is expressed in feet and t in seconds. Determine first the time at which the velocity will be 0. B, or the second question, is the position and the distance traveled by the particle at that time. Next, the acceleration of the particle at that time. And lastly, the distance traveled by the particle from t is equal to 4 seconds to t is equal to 6 seconds. Okay? Let's try and solve this problem. First of all, if you notice, we have x is equal to t cubed 6t squared minus 15t plus 40. T is time, x is said to be expressed in feet. Now what we need to know about x is, this is the position. In some books, position is usually denoted either x or s. Okay? So, try not to get confused. In this problem, x denotes our position or the position of the moving particle. Okay? So, I repeat, in some books, position is denoted as x, while in other books, position is denoted as s. While in this problem, it is denoted in x, so we'll have our solution in x. Start. So, we'll begin with what we have. No? We have the equation x is equal to t cubed minus 6t squared minus 15t plus 40. Okay? The first question is the time at which the velocity will be 0. Therefore, we need the velocity, or wait, no. We need the time at velocity is equal to 0. Okay? We have our position equation. We are asked with the velocity, the time, when the velocity is 0. Now, before I proceed with solving, just would like to clarify, the velocity mentioned in this problem, it is the instantaneous velocity. It is not the average velocity. Now, although it is not mentioned, if you notice, it is not mentioned anywhere in this problem whether it's instantaneous or average velocity. But the fact that we have an equation and there is no word average in the problem, it will give you a hint that the velocity mentioned over here, that it refers to instantaneous velocity. Okay? So going back to our solution, we have the equation. We need to solve the t when the velocity is 0. So what we need is, we need an equation that has v and that has t. Because if we have an equation that has a v, we can change the v into 0. And if it has a t, then it will give us the value for t. To do that, we are given with this equation. Okay? Now, we know the relationship between velocity and position. We know that velocity is the first derivative with respect to time of the first derivative of position with respect to time. Therefore, to get an equation of v that has a t, we simply need to obtain this one, dx over dt. We need to derive the position with respect to time. So deriving this one, this will now become, the derivative of x is 1, so we have 1. And since we're deriving x, it becomes dx. I repeat, the derivative of x is 1. Since when we are deriving x, then we have dx. The first derivative of t cubed, that is 3t squared. We are deriving t, so we have dt. Okay. Next, we have 6t squared, so this should be 12t dt minus 15. We are deriving t, it is dt. The derivative of a constant value is 0, so we have plus 0. We have dt, dt, and dt. We can factor out. 1 times dx is the same as dx. Factor out dt, we will get 3t squared minus 12t minus 15. Okay? Okay. We transfer dt to the other side. Divide both sides by dt. We get dx over dt is equal to 3t squared minus 12t minus 15. And we know dx over dt, that is now equivalent to our velocity. Okay? So we have velocity is now equal to 3t squared minus 12t minus 15. We now have an equation that has a velocity and time. So the first question is, what is the velocity, or what is the time when the velocity is 0? So we substitute the values. V is 0. We have 3t squared minus 12t minus 15. Okay. We need to solve this now. Now we can use our calculator. By the way, if you notice, this is a quadratic, or we have a t squared, which means this equation will give us two values for t. So we need to get those two values. Okay. We can go to our calculator mode, stat number 3. Okay. And then we have here 3, I believe. No. Mode, stat, and then, mode, shift mode, okay. 5 equation. There we have. So I repeat, we go to mode, then we go to 5, or we have the 5 equation. Now we choose our equation. We only have one variable, which is letter t. So in our equation in our calculator, we need to choose one variable. Number 1 in the calculator, we have x and y. Number 2, we have x, y, z. Number 3, we have only x, one variable, which is to the power of squared. So this is the equation that we will need. So we will click in the calculator 3. I hope you have at least a scientific calculator that can do mode equation. We have ABC. Now what ABC stands for, we can actually look back at the calculator. What is this ABC? If you notice, A, B, and C equal to 0. Meaning we need to set our equation in this form. So we have our equation equal to 0. Okay? The equation equal to 0. The coefficient of x squared is A. The coefficient of x is B. And the one without the coefficient is C. So we have here 3. First is A, the coefficient of the squared. So we have here 3. So 3. Okay. For B, we have negative 12. So let's put negative 12. For C, we have negative 15. Negative 15. Okay. Equals. Then we click equals again. We have the first value is 5. Positive 5. No? To be more specific, positive 5, we have, or the other value is, click pause again, negative 1. So we have now two values for t. Now which one is the correct answer? Since we are only considering the time when the motion began, then we will consider the positive value. Now what does this time negative 1 means? This is the time before the analysis in this problem. Any time that is negative, that represents the time which is happening before what is asked for us to analyze in the problem. Meaning, our analysis will only begin at time 0 up to positive time. Any time less than 0, which is negative time, we will no longer consider those in our analysis. Okay? So we'll get our first answer, which is time is equal to 5 seconds, or t is now equal to 5 seconds. Okay, we now have our first answer. The next question is the position and the distance traveled by the particle at that time. Okay, so the position will be easy since we already have the equation for the position. So all we need to do is substitute the value of the time. So we have x is equal to 5 cubed minus 6 times 5 squared minus 15 times 5 plus 40. We have x is mode 1 again. Okay, so 5 cubed minus 5 cubed minus 6 times 5 squared plus 40. You have 15. Okay, as stated in the problem, x is expressed in feet. So we have 15. Okay, 15 feet. Okay, and the other one is the distance traveled by the particle at that time. Okay, so the distance traveled by the particle at that time, distance traveled, you would get, that is, distance traveled is like this. We have 0.1 and you're going to 0.2. So when you go from 0.1 to 0.2, this distance will be your distance traveled. Okay, so the question asks, what is the distance traveled by the particle at that time? Meaning, what is its distance traveled from time is equal to 0 up to time is equal to 5 seconds. Okay? Okay. So we have, the question is, the distance traveled by the particle at that time. Now notice it did not made mention the reference time. So we can assume, or we can safely assume, that it means what is the distance traveled starting from time 0 up to the time 5 seconds. Okay. Now as I've said, at time 0, the object will be at 0.1. And since our object is moving at time 5 seconds, it is now at 0.2. So the difference in distance for time 1 and time 2, or at time 0 and time 5 seconds, that is now your your distance traveled. Now how do we solve that? Okay, we can use the position. Okay, position is basically your location from a reference point. At time 0, if we substitute it for A, no? At time is equal to 0, the position would be equal to, we have here, substitute 0, this would be 0 cube minus 6 times 0 squared minus 15 times 0 plus 40, okay, equals 40, okay, 40 feet. This means that at time 0, the particle is 40 feet away from a reference point. No? Let's say, for example, this is now our reference point. So at time 0, no, this is 40 feet. Okay. At time is equal to 5 seconds, what will be our x? So we have our x is, this is t, 5 cube minus 6 times 5 squared minus 15 times 5 plus 40. Okay, we have here checking 5 cube minus 6 times 5 squared minus 15 times 5 plus 40. Okay, so the answer is negative 60. So negative 60 feet. Okay, so we will use, by the way, position is a value that has a sign, so we will use negative 60. So let's have a more accurate representation of the position. So if we have here the reference point, no, where the position is referred, at time is 0, x is 40. So to have a more simpler analysis, we'll use a line. We have here, this would be at time is equal to 0, and this is equivalent to 40 feet. And at time of 5 seconds, it's located now at 60. Negative, this is at time is equal to 5 seconds. This distance is what we have, negative 60 feet. Okay. Now, first question, how do I know it is a straight line? No? Why not I put a 60 going vertical or 60 going downward? Okay. It states in the problem that the position of a particle which moves along a straight line. Although it is not mentioned it is vertical or horizontal, it made mention of a straight line. So our representation here, it is a horizontal line. You can still solve this using a vertical line. What's important is you use a straight line. So we have here a straight line. Now I just chose the horizontal line because it's much more simpler in my view. So we have at time 0, the location is at this point. And then what happened is our particle was moving in a straight line. So at this point, it moved slowly. After 5 seconds, it arrived at this point. So the question is, what is the total traveled distance of our object? So that is simply this distance. Okay? Or we could actually use the displacement, or we can use the displacement formula for this one. We have its position at 5, okay, at position at time 0. So we have negative 60. So we have here negative 60 minus 40, and we will get negative 100. But since we are looking for the distance traveled, then it should be positive. So the distance traveled, that is equivalent to 100 We have now our letter B. Okay. The distance traveled is 100 feet. Now the next question is the acceleration of the particle at that time. So we also need an equation that has an acceleration and time. We already have our equation for the velocity. Okay, and we know that acceleration is equal to the derivative of velocity with respect to time. Okay, so simply derive here dv times 1. We have here the derivative of v is 1. We're deriving v, so we have dv. This becomes the derivative of 3t squared, that is 6t. Derivative of negative 12, so negative 12 minus 0. And this is dt, no? Since we're deriving t. Transfer dt, then we'll have dv over dt. dv over dt is equal to 6t minus 12. And we know dv over dt is acceleration. Okay, so we have our equation here. The question is, what is the acceleration at that time, or at time 5 seconds? So we substitute a is equal to 6 times 5 minus 12. We'll get, I believe 6 times 5 is 30. 30 minus 12 is 18. So we know 18. The unit should be feet per second squared, since this is an acceleration value. Okay, so we have it there for our answer for letter C. Now the last question is, what is the distance traveled by the particle from time 4 seconds to time 6 seconds? So we'll do the same straight line. Okay, we'll have it here, the reference point. Okay, time of 4 seconds. So what we need here is, at time 4 seconds, what is the position, and at time is 6 seconds, what is the position? Okay, do we have this solved? No, we only have 5 time 4 0. So let's try and solve. At time of 4 seconds, we have here 4 cubed minus 6 times 4 squared minus 15 times 4 plus 40. We have negative 52. Checking, negative 4 squared, negative 4 cubed minus 6 times 4 squared minus 15 times 4. Negative 52. Okay, negative 52 feet. We also have 6 now, times 6 seconds. 6 cubed minus 6 times 6 squared minus 15 times 6 plus 40. Checking, 6 cubed, 6 is squared, 15 times 6, 40. So I have here negative 50 feet. Okay, so let's have it here. The reference point, okay, at time is 4 seconds. It is located, this is negative 52, so it's somewhere over here. This is a time 4 seconds. No? This is distance of negative 52 feet. While at, what's this? Time 4 times 6 seconds is negative 50. So over here, at time 6 seconds, it is now negative 50 feet. Okay. Now if you look at this closely, no? This is at time 4 seconds, this is at time 6 seconds, and the question is the distance traveled by the particle. Note that the question is the distance traveled. The question is not displacement, but the question is distance traveled, meaning if we go back to the question at letter B, the distance traveled was 100 feet. That is because the particle started at time 0, then it moved time 5 seconds. So this is the traversed distance, which just happens to be 100 feet. Now if we look at it here, we might think, okay, the object was at here at time 4 seconds. The object is now here at time 6 seconds. Therefore, the object must have traveled from here up to here. So this would be a total of only 2 feet. Okay. Now if your answer is 2 feet, then that would be wrong. Now why? Going back at the first question, the distance traveled is 100 feet. Starting at time is equal to 0, we have the object moved from this point up to 5 seconds, this point. Now notice that the time 50, that is when our velocity was 0. Okay, the time 5 seconds, that is the velocity is 0. Now what this means is that initially at time 0, our object had a velocity. It had a velocity which is moving in one direction. Judging from this figure, it's probably moving to the negative direction. Okay, until when it reached here at time 5 seconds, okay, its velocity is now 0. So meaning the object is starting here, it had a velocity, it slowly moved its way. After a few seconds, it arrived here. Now its velocity is 0, meaning the velocity was slowly changing in value until it reached at a velocity of 0. Now, of course, the direction was the same from time 0 is equal to time 5 seconds. Now, how do I say that the direction or the direction is constant within that time? When we solve, this is the equation for the velocity, by the way. So this one, this is the equation for the velocity. When we say changes in velocity, or the changes in direction of the velocity, that is when your velocity reaches at point 0. So meaning our velocity would be, for example, let's have 5 is the 5 meters per second. Depending on the amount of acceleration, if it's a positive or a negative acceleration, then this value will change. It can grow bigger if it's positive, it can grow smaller if it's negative. Okay, so before it can change its direction, if this is positive 5 meters per second and we have a negative acceleration, this means that it is now a positive 5 meters per second. It is moving at the positive direction. Before it can change towards the negative direction, it needs to slowly decrease in value until it reaches 0 acceleration before it can start with a negative acceleration. Negative velocity, meaning it has an initial value which has an initial direction which is going to the positive. For this example, we are going to the positive direction. Before it can change in direction, it needs to reach the value 0. After reaching value 0, it can now change its direction. Now, from our solution, the only time that the equation will have a 0 velocity is at time 5 seconds and at time negative 1 second. Now, since we'll only consider the time 5 seconds, therefore, from our analysis, only during the time 5 seconds, the object changed in direction. So over here, the object started at time 0 until it reached time 5 seconds. Since there are no changes in direction from time 0 to time 5 seconds, therefore our object was moving in a straight and same direction from time 0 to time 5 seconds. So it's just moving at a straight line without changing direction. So we have this straight line distance traveled. Now let us consider this one. Okay? The time 4 seconds and the time 6 seconds. Now, if we include the time we have here, the time 5 seconds is negative 60. This is the time 5 seconds. This has a distance of 60 feet. Okay? Notice that the time 5 seconds is between 4 and 6 seconds. Now, what this means is that at time 4 seconds, the object was over here. At time 5 seconds, the object was over here now. Or this is negative 60. So I repeat, at time 4 seconds, the object is over here. At time 5 seconds, the object is over here. At time 6 seconds, the object is over here. Meaning the object changed in direction. Because we knew from our previous solution that velocity becomes 0 at time 5 seconds. Therefore, it changed its direction. So if we were to rewrite our figure, this would be at time 4 seconds, the object moved to the negative direction to reach the time 5 seconds. Okay? The object started here, moved to the negative direction until time 5 seconds. Now, from time 5 seconds, it moved to the positive direction until time 6 seconds. Okay, so therefore our object moved from point here, it moved over there, and then it moved again there. Now the question is the distance traveled. I repeat, the question is distance traveled. The question is not displacement. Okay, the question is the distance. The question is the distance traveled. The question is not displacement. So therefore, the question is, what is the distance that the particle traveled from time 4 seconds to time 6 seconds? Or so the question is, what is the distance it passed or it traveled? So if we look over here, it traveled here to the negative direction and then to the positive direction. So what we need is the value or the distance, this one, plus the distance traveled over here. Now from time 4 to 5, this would be it traveled, this is equivalent to the difference. No? So we have here the distance traveled. Okay, distance traveled. Okay, so from time 4 to time 5, how much is the distance traveled? We have here a total distance of 60, a total distance of 52. Therefore, their difference, that is equivalent to 8 feet. So it traveled an 8 feet distance from time 4 to time 5. I repeat, at time 4 to time 5, it traveled a distance of 8 feet. It started here, it moved over here. Now this has a distance of 60, this has a distance of 52, therefore this distance is 60 minus 52, which is equal to 8. Okay. Now the distance traveled from time 5 to time 6, so that is time 5 to time 6. Okay. This distance is 60, this distance is 50, no, the time 6. So therefore this excess or the distance traveled here from 5 to 6, that is 60 minus 50. Now that is 10 feet. So the distance traveled is equivalent to 18 feet. Oh, this is oh, excuse me. 18 feet, that is letter D. Okay, 18 feet. So I repeat, at time 4, it traveled here 8 feet, and then from time 5 to time 6, it traveled another 10 feet. So that is a total of 18 feet. So be careful. Just remember that it changed its direction when the velocity was at 0. You might be tempted to give an answer of 2 feet, no? From 4 to 6, that is actually 2 feet. But that is not actually the actual path that the object took, no? It moved from 4 to 5, from time 4 to time 5, going to the left, to the negative direction. And then from time 5 to time 6, it now started to move to the positive direction. So its total distance traveled was 8 feet going to the negative, 10 feet going to the positive direction. So we have 8 plus 10, that is 18 feet. No? Or simplicity, it moved 8 feet to the left, it moved 10 feet to the right. So its total movement is 18 feet. Okay? That is all.